All right, let's see. It says trig in the coordinate plane, all right, which means x and y axis, all right, not that big of a deal. It might look real confusing if you just flip the pages and look at it, and Simone's freaking out. Okay, it's not near as bad as when you just break it down into what I'm going to do. So let's talk about this thing first. So let me just do an x and y axis. Okay, and I'm going to put an angle in here. Let's make it, we'll just make it this blue color. And let's make this a 2-point line just so it's a little bit thicker. There we go. And I'll bring it up to there. And then I'm going to put another one on here and go to about right there. All right, I'm going to put arrows on the ends of these. So here's my angle. Do you see the blue angle? Pretty easy to see. All right, would you agree? All right. This is an angle that's considered to be in standard position. All right, so this is the standard position. Standard position is this part of that angle. Okay, it's a ray, if you remember from geometry. Okay, so that would be a ray. That is the initial side, we call it. So we're just going to go through some vocabulary first. Initial side. So this is where it starts, initially, right? If something is initial, that means it's starting there. And this is the terminal side. The terminal side is where it ends, all right? So that's where the angle ends. We call that the terminal side. Terminal side. You don't need side in there, okay? Everybody with me? So it starts here, and it goes like that. Everybody see that? All right. So that's our angle. Let's put some degrees in here. If I go to the positive right, this would be going at 0 degrees. Okay? What about if I'm going straight up and down? If this is the initial angle, what degree is this? 90 degrees. If it goes this way, which angle would that be? Be 180. And then, what about this direction right here? Again, we're going from here, like from here to here would be 90, and then from that initial side to here would be 180, and then if you go all the way to here, 270, right? It's 270. How'd you get that? Each one of these are 90 degrees. Everybody see that? So that's 90, that's 90, that's 90, so 90 plus 180 is 270. And if you go all the way around, guess where you're going to be? 360 if you go all the way around. Okay? And we could keep going around and around and around and around depending on how many times we want to go around. So this could be 90 what? Plus 360, right? If I go around once and then go back to here again, that'd be 90 plus 360. What if I went here? If I went all the way around to here, that's 360 plus another 180. I could do that if I wanted to. All right, but that's pretty important. But you can also go the other direction. If I go, what would that be? Counterclockwise? I watched a British show last night. They call it anti-clockwise. Did you ever hear that before? Anti-clockwise. I thought that was funny. I said something to my wife. So I got to tell my math class that because, all right, so she didn't care. All right, so, and I'm sure you don't either. So watch, what if I start here but I go the other way? What if I went clockwise from here all the way to here? How many degrees is that? Well, actually, I didn't tell you what angle that was, did I? All right, so I should do that. Let's make that a different color. So I kind of got ahead of myself. Thought I made it red. Hold up. There we go. All right, so let's call this one 50 degrees, just to make it an easy round number, okay? So if that's 50 degrees, this would be a positive. Going this way, going counterclockwise, is going the positive direction. So this would be positive 90. And then if I go to here, positive 180, positive 270, positive 360, because I'm going in this direction, okay? What if I go the other direction? What if I actually go clockwise? That's actually like the backwards direction. All right, this would be negative, correct. Now, what would the green one actually be? No, it'd be 310. It'd be 310, right? So if I started here and I went all the way to there, that's 270. Or you could think of it this way. Go all the way around to here and then back up 50, right? So 360 minus 50 is what? 310. But you're going in the opposite direction. Very good. You're going in the other direction, so that would be a negative 310. So this angle could be named two different things. It could be positive, let's change this back to white. We could name it positive 50 degrees. I'll put the plus there. You don't really have to put the plus if it's positive, but I'll just do it. Or it could be, what else? Negative 310 degrees. Do you see that? We say that that angle, these two angles right here, you end up at the same spot, don't you? Right? But you get there two different ways. We call that coterminal angles. Coterminal. Because they both are terminal, they both finish at the same spot, but we went different directions to get there. So if you go counterclockwise, that's the positive direction. If you go this way, that's the negative direction, okay, clockwise, and so you put a negative on there. So it's the same thing. 50 degrees and negative 310 degrees is the same angle. You just got there two different ways. You got it? Okay. Let's see what else I want to do. So what would the coterminal angle be for 90 degrees? So if you go this way, the positive direction, that's 90 degrees. What would this be if you went from here this way? What would this spot be right here? If I went from here to here, it would be negative 270, right? So positive 90 degrees is the same spot. You end up at the same spot as you would if you went negative 270 degrees. What about 180 degrees? If I went from here to here, positive 180, what if I went the other way? What would that be? It'd be negative 180. Good. Still went 180 degrees, but you went there different ways, right? You took a different route. What about this one? It's positive 270, because if I started here, I went all the way to here, that'd be positive 270. Or you could go this way, the opposite direction. So what would this be? Be negative 90 degrees. Connor, take that thing out of your ear. All right. Does that make sense? Yeah. All right, let's do a little example with all that said. Once you get used to these, it becomes second nature to you. You hardly think about it. But you use this a lot. You use this a whole lot when the more and more trig that you do. So here's example 1. And they give you an angle. It's given that theta is equal to 210 degrees. So what we're going to do is first of all, it asks you to do 3 things. We'll just do one at a time. Okay? It asks you to draw the angle in standard position. All right? So we got to figure out, where is 210 degrees? Well, this is 0 degrees, this is 90 degrees, this is 180, and this is 270. What quadrant do you think 210 is going to be in? Again, we're starting from here and we're going this way. What's that? Give me a number. Quadrant. Third quadrant, right? This is a third quadrant. So where is it going to be? Let's do this. I'm going to do the whole initial side and terminal side, all right? So there's the initial side right there. So where am I going to put 210? It's going to be in the third. You think it's going to be down here? You think it's going to be smack in the middle? You think it's going to be closer to here? Yeah. So because if you went 180, how much more do you have to go to get to 210? You got to go 30 more. So really, it's just a 30. It's a 30 to the 180. Would you agree? All right, so that, whoops, let's make that smaller or thinner. So this would be 30 degrees right here. But the whole angle is what? It's 210. Does that make sense? All right. Now that angle right there to the x-axis, right? If I take this to the x-axis, We call that angle a reference angle because of what we're going to do in a little bit. All right, so that's called a reference angle. Okay, this is the whole terminal, right? So that's your angle from there to there. You could go the other way too, couldn't you? And that's the part B. So the part A, they asked you to graph it, all right, or draw the angle. They don't say graph, but they say draw the angle in standard position. Part B, they said identify a positive and a negative coterminal angle. So this angle right here, give me another positive. It's already 210. Give me another positive angle starting from here to here. We talked about this a little bit earlier. You could keep going around the circle more than once, couldn't you? Right? So you could start here. That's already 210. That's already used. I'm not going to use that again. So what could we do? We could go to here. That's 360. What? Math-wise. 360. Yeah, give me what? Plus, right? 210. You see that? What's that? Later on you'll see, okay? It'd take too long to talk about why. We're just learning the basics right now, okay? So that would be a coterminal, another positive angle that ends right here, all right? So how did you get to it? Now, if I just went from there to there, it's already 210. So that's not really a coterminal angle. I need another positive. So what do? Just add a 360 to it, all right? So that whole thing right there, right? You've seen skateboard and stuff, right, where they do and they twist and they say, oh, they did a 720, they did a 1440, they, you know, all that. Well, that's what this is. What did you do when you did, and you ended up right here? You went 360, one full turn, and then you went another 210 degrees, all right? So what is that? 570. So 570 would be one positive. Is there just one other coterminal? No, I could have added another 360, another one. I could have kept on going in circles all day long. But what do? You take the 360, you add it to that angle right there, which is 120. How do you get a negative coterminal angle? That's it. Okay? If you wanted a negative coterminal angle, because we haven't talked about that, you could just do what? Whoops. You could go 360, what? Minus 120. Actually, let's do it the other way around, because I want a negative angle, don't I? So we're going to go negative 360 plus 120. Agreed? Because that'll give you a negative angle. Oh, yeah, that's right, isn't it? Oh, 210. What did I say? Yeah, is that what you're telling me? Okay, I couldn't hear it. Yes, my bad. 210. Okay, or you could have just gone 210 minus 360. Give you the same thing, wouldn't it? Yeah. And what's that? Negative 150? Yeah. All right, so that yellow angle right there is negative 150. Those are coterminal angles. So the question was, give me one positive coterminal and give me one negative coterminal. Now, if I wanted to, I could have gone negative 720 plus 210, couldn't I? I could have kept on doing increments of 360 if I wanted to. But why do that? That would be nonsense, wouldn't it? All right, so let's just keep it like that. So 570 would be 1. That would be your positive coterminal, and negative 150 would be your negative coterminal. Now, they ask you something on part C. I almost didn't even write down, but I'll talk about it super quick. It says, write an expression representing all of the coterminal angles. That means I go around once, right, and then to the angle, or I could go around twice or 3 times, 4 times, 5 times, 100 times, 1,000,000 times. How do I represent that? Well, it would be this. What do we do to this? We started off with the 210, correct? And we added a 360, but then if you multiply that by n represents the number of rotations, okay? So this could be, if n is 1, it would just be 570, right? If you go around twice, that's 720. If you go around 3 times, whatever that is, okay? So the n represents how many rotations you have. So that's another way to write it, okay? and n has to be an integer. Yeah, enough of that. Let's move on. All right, here's something. It seems like it's way different than what we just did, but it's really not. It's kind of going to bring everything together here, I think. So let's do this. And let's put an angle. Since we've been doing blue, light blue, I'll do the same with this. Let's make it a little thicker again. So let's just go to here. I'm sorry. Yeah. And let's go to, come on, there. Oops. There we go. Doesn't matter really how much you stretch it out. So there's an angle right there. We're going to do something here with this. Let's make this 1 point, make it red. All right. What I'm going to do is take this angle, and then I'm going to take anywhere on there. It doesn't make any difference. Just let's say right there. And I'm going to drop a perpendicular to the x-axis. You hear what I just said? I'm going to drop a perpendicular down to the x-axis. If it's perpendicular, that's a right angle. You see that right triangle we have right now? Okay, that's a really important right triangle. I'll tell you what, let's just do this in red. We'll go to there, and then we'll go to there. Just so I can say, look at that red. Come on. Yeah. Let's make that a little thicker. Same thing with that. Just so I can see it a little bit better. There we go. Now, this is going along the x-axis, correct? Let's say this is theta. I'll do this in a different color. All right, so let's say this is theta. This is going along the x-axis, so I'll call that little bit from here to here, that red one, call it x. What do you think I'm going to call this one right here? Call it y. Very good. All right, and then I'm going to call this r, that hypotenuse, we're going to call it r. Why r? Is that what the question was? Yeah, I agree, but there is a reason for it, because we're going to learn something later on called the unit circle, and this right here is the radius, you see? The radius of a circle that goes around like this, okay? So that's why they call it r. All right, so what I want to do is I want to write down my trig functions with this particular triangle, all right? So let's do them pretty quick. So the sine of theta, cosine theta, tangent theta. And we can also throw in our inverse ones, cosecant, secant, and cotangent. This should be pretty easy. This isn't really anything new. But setting it up on an x and y coordinate system, that's what's new about this, all right? So what is the sine of this angle? What over what? Y over r, because it's opposite over hypotenuse. So it's y over r. The cosine is adjacent over hypotenuse, so it's x over r. And the tangent is opposite over adjacent, which is y over x. You with me? Cosecant is the inverse of the sine, so you don't have to go opposite, hypotenuse, adjacent, but we can just look at this and just reverse them, right? So this is going to be r over y. Secant's the inverse of the cosine, so this is going to be r over x. And the cotangent's the inverse of this, so it's x over y. I'm not really worried that you memorize these, but these are important right here, all right? What if, yeah, I'm not even going to get into that. Let's do this. Let's get r by itself, and let's write r in terms of x and y. What does that mean? I want r equal, and then I want x and y kind of in my answer. All right, that's what it means in terms of. Pythagorean theorem, perfect. It's exactly right. Because I got a right triangle, I could solve for r. What would I do? I would take this squared plus this squared equals this squared. So really, r squared equals what? X squared plus y squared. Get r by itself, so r is equal to the square root of x squared plus y squared. We're going to do more with that at a later time, all right? This is all just kind of getting you ready to do more stuff, all right? This isn't in and of itself the end, it's the beginning, of what we're going to do, all right? So just kind of keep all that stuff in mind, all right? What we're going to do eventually is we're going to make that r equal to a 1. What did I call that circle? Do you remember? I only said it once. I called it a unit circle. What is a unit? It's 1, okay? So when I talk about a unit, we talk about the number 1. So we're going to do more stuff with that. I'm not going to get into that right now because we got too much to do right now, all right? So we'll put that on hold for a second. So now we're actually going to do an example. So let's see if we can take some of the stuff that we've learned about and actually find some stuff that they want you to find. It says state the 6 trig ratios of theta in standard position if its terminal side passes through the point 5, negative 12. That's too much to write, so I'm just going to write 5, negative 12. So what I'm going to do is I'm going to draw an x and y axis, a coordinate plane, and I'm going to put that point 5, negative 12 on that plane. So 5, it doesn't have to be perfect. Go over 5, go down negative 12, probably something like that. May not be exactly to scale. It's good enough. And again, I'll go in blue. So what I'm going to do is I'm going to connect the origin with that point. And then, what did I do over here to make that triangle? I made it perpendicular to the x-axis, didn't I? So that's exactly what I'm going to do right here. So I'm going to take this, and I'm going to make it perpendicular to the x-axis. And I'll show you why I'm going to do that in a second. Everybody see that? All right, so it's a right angle. Now I know a couple things about it. What was this point? 5, negative 12. So that means how far did I go over? I went 5, right? So the length of that part of my triangle is 5. How far did I go down? I went 12, right? I went down, so it's negative 12. You with me on that? So what they're asking is state the 6 trig ratios: sine, cosine, tangent, cosecant, secant, cotangent. Okay, they're asking for those 6 things with this situation right here. All right, so they are asking for the sine of that angle. So that angle is this angle right there. All right, it's the one that's formed to the x-axis. You got it? It's from the terminal side. This is my terminal side, and it's the angle that's formed with that x-axis. Don't take this over to the y-axis. That changes everything up, okay? Messes everything up, all right? Just always take it to the x-axis, and we've got this right here. So we want to find the sine, the cosine, and the tangent of that angle. All right, so what is it? What is the sine? It's opposite over what? Hypotenuse. Problem is, I don't know the hypotenuse. How do I find that hypotenuse? Pythagorean theorem. This is actually one of our Pythagorean triples. Do you remember the Pythagorean triple? Remember 3, 4, 5, don't you? There's also a 5, 12, 13. And then there's like an 8, 15, 17. Oops, 17. And then there's a something 24, 25. I always forget that one. That's a small number. It's like 9, 24, 20. I forget what it is. You can look it up. Thank you. Okay? So anyway, so what is this? What is that hypotenuse? It's 13. So now we're ready to find the sine, cosine, and tangent of that stuff. Okay? And we can also, they don't do that in here. I don't think they do that in this lesson. No, they don't. But you could actually find what the angle is. All right, knowing that point right there, you could actually find that angle. We're not going to do it on this lesson. We'll do it some other time. So let's find the sine of the angle. So the sine is what over what? Opposite over hypotenuse. So it's negative 12 over 13.
So is it just negative because it's the form of point?
It's negative because it's in the 4th quadrant, and the y in the 4th quadrant is always negative.
So like if we had just a triangle, and like last week, let's say we had a triangle, would it have been negative? Or is it just
I think last week we stayed in the 1st quadrant, I think.
Are they always in quadrants?
Yeah.
Or just like
Yeah, because this is x, y, right? So it's, well, it could be. Actually, we're going to do one that's actually on the line itself. But we'll talk about that when we get to it. All right, so here we go. No, I appreciate your interest. It's better than having a hand up saying, can I go to the bathroom? I like that so much better than the bathroom question. All right, so cosine of this angle is what over what? 5 over 13. Okay, and then the tangent is opposite over adjacent, so it's negative 12 over positive 5. Yes? You should have, yes. I told the class yesterday during class, but I did not mark it wrong, though. Even though I said, for those who didn't reduce, even though I said, make sure you reduce those, about 2 or 3 did not, but I didn't mark it wrong. All right, wasn't that nice of me? So now, the rest is easy. Do I have to do the inverse? Let's not. Okay, cosecant, secant, cotangent, you just flip these, no biggie. So that's what they're asking you to do on that example. All right, yeah, that's that. Now, you asked the question about what if it's not in a quadrant? Now we're going to answer that. Okay, so let's do the x and y axis again. So what if I asked you what the sine, cosine, and tangent of 180 degrees? So where is that? Well, it's right there, correct? So let's draw it. So we're going from here to here. And really, you're starting here and you're going to there, right? And we can't really take this up to the x-axis because it's already on the x-axis. So let's figure out what this point is. Let me see how I do that. Oh, you know what? I was looking at the wrong thing. We are not going to do the 180 just yet, I don't believe. Did I finish that? Yeah, finish that. Okay, and then that was example 2 we did before, right? Oh yeah, okay, I am on this one. I don't know why I was thinking I wasn't. So we want to find the 6 trig ratios, sine, cosine, tangent, cosecant, secant, cotangent of 180 degrees. So this is at 180 degrees. We can't really make a triangle out of that though, can we? Right? Because it can't really drop it up or take it up to the x-axis. But I do know where that point is. Again, I kind of mentioned unit circle. So let's make that hypotenuse, let's make that angle equal to 1. Okay, the length is 1. So what would this ordered pair be if this whole blue length right there was 1? What would it be? The ordered pair. Is it 0, 1? 1? It's negative 1. You're going to the left, right? Aren't you? You're going to the left. So this would be what? Negative 1, what? 0. So that's that point right there. A little bit later on we can look at this a lot easier, but I haven't taught you everything I need to teach you right now. Do you remember what that sine, let's do this. Let's write it like this. The sine of 180. Do you remember what it was with the x and the y and the r? Do you remember what it was? Look at it in your notes. What was the sine with the x and the y and the r? How did I write it? Wasn't it y over r? Yeah. All right, we'll get to that in a second. What was the cosine? X over r. And then the tangent? 180. What was it? Y over x. Okay, so let's think of that. Now, what's our x and our y? Our x is negative 1, and our y is 0. What's our r? It's the length of this. It's 1, isn't it? Yes? Okay. So, what do we write? 0 over what? Because it's y over r. So the y is 0 over the r, because r is 1. And what is that? Put it in your calculator. Put in sine of 180. See what you get. Who's got a calculator out?
What is sine?
Sine is the opposite. It means it's a word that describes the opposite side divided by the hypotenuse. That's what the sine is.
What is it find? What is it like? Is it like the angle measure?
Yeah, so that's what it is. It's, watch, if it's the sine of 38, if I ask for the sine of 38, it's this over this. Well, it's finding the ratio. It's finding the ratio of y to r. So whatever y over r is, whatever length that is, if I take y divided by r, that's the sine of 38 degrees. Okay?
No, but like,
No, I think I answered your question. I don't just.
So is the point of sine just to find other things? Is that
Well, it helps you to. Yeah, sine, cosine, tangent helps you find different sides and angles that you wouldn't have been able to before. All right, let's keep going. We can't get all philosophical about it just yet. We got a lot more to do. Okay. So what is this? The cosine of 180. What is that? It's -1. It's x over r, correct? So it's -1 over what? 1, because r is 1. What is -1 over 1? It's -1. Anybody doing this in your calculator? Did you get the sine of 80 to be 0? Yeah. Did you get the cosine of 80 to be -1? Yep. This is why. All right. This is the reason why your calculator gives you those answers. What about the tangent? The tangent's a little different. Watch. The tangent, actually, it's on the next one. It's a little different. The tangent is the y over the x. So what would that be? 0 over -1. What's 0 over -1? It's 0. Okay? Now let's do it over here. Let's do the cosecant and the secant, because this comes out a little different. We kind of skipped it before, right? All we do is flip it. But this time when you flip some stuff, I shouldn't put theta. What should I put? Because I should put 180. All right, so the cosecant of 180, secant of 180, and the cotangent of 180. Now watch. A couple weird things happen here. The cosecant of 180 is just the inverse of the sine. So it's 0 over 1. How do I find the inverse of 0 over 1? It's 1 over 0. But what's 1 over 0? It's undefined. That's right. It doesn't work. So there is no, it's not 0. It just doesn't exist. There's no cosecant of 180 degrees. All right? What about the secant of 180 degrees? Well, it's the inverse of the cosine. So that would be +1 over -1, which is still what? -1. So that gives me an answer. What about the cotangent of 180 degrees? Well, again, what was the tangent? It was 0 over -1. Flip it, you'll get -1 over 0, which again is what? Undefined. And so it doesn't exist. There is no cotangent of 180. How could you figure that out on a calculator? Well, this is the inverse of the sine, so find the sine of 180, right, which is 0. You probably have an inverse button on your calculator. Did you realize that? You got a 1 over x button on your calculator. Anybody see that before? If you hit that, that's what it does. It takes the inverse of it, all right, and that'll give you, it's undefined, or error. It'll give you some kind of error message, okay? All right, enough of that. Let's talk about some reference angles. We only got 5 minutes. I think I can skip a little bit of that intro stuff and go right to the example, because I think I've said enough. I know. At first, it is confusing. I agree. But after a while, you start liking it. I love this stuff. There's some stuff I don't like doing, but I like doing this stuff. All right, so watch this. What is a degree? It's 1/360th of a full circle.
So how do they find it? Would they just be like, let me just divide us up? Do they do it from a formula?
You're asking all these deep questions. I'm trying to teach you something specific here. Come on, stick with me. That's not going to help you. It's not going to help you do these problems. So it says, again, do the 3 basic. We're not doing the inverse ones. We're just doing sine, cosine, and tangent for each of these. And this is part A, and it says 210 degrees. So guess what we're going to do first? We're going to draw 210 degrees. We've done it already. We've done it once already. So where is 210? Well, that's 180. How far down do I go to get to 210? I go down 30, correct? All right, so watch this. You'll find that this is not near as bad as what you think it would be. All right, so I went 180, then I went 30 more, correct? So let's put that 30 in here. Right? That's 210. Would you agree? This angle right there is pointing where? At 210 degrees. Because this was 180 degrees. I went 30 more. That's 210. Right? Okay. And what did I do? I dropped up, or drop up or down, however you want to say it. Okay. I made a perpendicular line to the x-axis. Remember, don't take it to the y-axis. Pop it up to the x-axis. Now I got a nice little right triangle, don't I? You with me on that? So what I need to do, and this is a special triangle, so we can actually do this. This is a special triangle, 30, 60, 90. Remember that? What we're going to do is make the hypotenuse 1 because it's a unit circle. We haven't really officially talked about it, but I mentioned it a little bit. So we'll say the radius is 1. Okay? So what's that going to give? What's the short side going to be if the hypotenuse is 1? It's a half. It's a half. How do I find the long side? Remember doing this in geometry? It's the square root of 3 times the short side. So what would that be? Square root of 3 over 2. You with me on that? Okay. So let's check this out. This is kind of cool. It doesn't matter which one you do first, but it seems like they always do the sine first, so we'll do that. So watch. Just with this information, I can figure out what the sine of 210 degrees is. By the way, this goes down, so I should have put a negative right there. This goes to the left, so I should have put a what? A negative right there. Everybody see that? Because how did you get to this point? At 210, you went left, you went down. Negative, negative. Okay? So watch. Without using a calculator, you can figure out what the sine of 210 is. So what's the sine? It's opposite over hypotenuse, which is negative 1/2. Agreed? What's the cosine of 210? It's adjacent over hypotenuse. What's the adjacent? It's negative square root of 3 over 2 over 1, right? It's the adjacent over the hypotenuse. Over 1, don't really need it. What's the tangent of 210? Okay? It's opposite over adjacent. So it's negative over negative, so I don't have to worry about that. That's positive. So it's 1/2 over the square root of 3 over 2, correct? Now we got to do a little work here. So it's 1/2. Instead of dividing by a fraction, what do? Multiply by the reciprocal. See what's happening? The 2's cancel. This is 1 over the square root of 3. We don't like that. Why not? Because you got a square root in the denominator. So you multiply top and bottom by the square root of 3. So you get square root of 3 over 3. Look, put this into your calculator. If you put the sine of 210, you're going to get negative 0.5. If you put in the cosine of 210, you're going to get whatever that is. And it's like 0.8660 or something like that. All right, I don't know what the square root of 3 over 3 is as a decimal. But there you go. Without using a calculator, you were able to find the sine, cosine, and tangent of that angle, which I think is a kind of cool thing, right? You can't do that with like 38 degrees because it's not a special angle. But 30 and 60 and 90 are all special angles, and you can find the sine, cosine, and tangent of all of those without ever using a calculator. We had one more to do, but we got pretty far. So get your homework done, even though you guys are walking out on me. It's a 1 to 35 odds. You're already crying about it earlier, so everybody knows. It's 1 to 35, but you're only doing the odds. And this is section 10.3. There you go.